Hello, everyone, and thank you all for joining us. The views, opinions, and technical analysis presented during this webinar are those of Evonik and not necessarily those of UL. The appearance of this content on UL sites does not constitute an endorsement by UL or its affiliates. Today's webinar is More Sustainable Epoxy Adhesive Solutions with Ancamine and Ancamide Epoxy Curing Agents. Today's event is presented by Evonik, and your presenter today is Sébastien Clermont. Sébastien obtained his doctorate in macromolecular chemistry for interactive materials, EV, before joining Evonik in 2020. He gained several years of experience as a product developer in the field of epoxy adhesives for automotive body shop applications. At Evonik, he is responsible for application technology of the adhesive and composite relevant products for epoxy curing agents product line in the Crosslinkers business line. My name is Abby Pirro, and I'll be moderating today's event. Please send us your questions by typing them in the question tab located on your screen. We are recording today's event and we'll send you a link by email when it has been posted to prospector.com. Now I'd like to turn the presentation over to Sébastien. Would you like to begin?
Okay, yeah. Thank you for the introduction, and also from my side, thank you for taking the time to attend today's webinar about the more sustainable epoxy adhesive solutions with Ancamine and Ancamide epoxy curing agents. It's a pleasure to have you here today, and also many thanks to the UL Prospector team for organizing this. So first of all, before we dive into the topic, I want to give you a short introduction on Evonik and the product line epoxy curing agents. So basically who we are and what we do there. As already introduced, I'm working for Evonik in the function of technical application manager at the business line Crosslinkers with a focus on the adhesive and composite related epoxy curing agent. That sounds quite easy, but due to the size of Evonik with a complex structure, it may sometimes be challenging for you to find the right products and most importantly also the right people there. To show you where we fit into the Evonik cosmos as epoxy curing agents and where you can find us, we'll start with a brief overview, including some facts and figures, as well as an overview over Evonik's organizational structure. So Evonik is one of the world leaders in specialty chemicals. We are active in currently more than 100 countries with over 33,000 employees around the world. So in 2021, we generated sales of around 15 billion euro with an operating profit of around 2.5 billion euro, which corresponds to a EBITDA margin of around 16%. And following our common purpose, which is we want to improve life today and tomorrow, we go far beyond chemistry to create innovative, profitable, and also sustainable solutions for our customers, which is also reflected by a relatively high share of R&D expenditures of around 460 million euro in 2021. Coming now to the organizational structure of Evonik, which is currently we are divided into 5 divisions. So here each one is dealing with different kinds of chemistries and also different kinds of application fields. And within this spectrum, we, the product line epoxy curing agents, we are localized in the business line Crosslinkers, highlighted here in purple, as a part of the specialty additives division. So this is basically where you will find us in the more or less complex Evonik cosmos. Coming now to the business line Crosslinkers to get a bit more into detail. Here we are the leading supplier of isophorone chemistry and technology leader in epoxy curing agents with strong competencies, particularly in the fields of acetone condensation, hydrogenation, and also urea isocyanate chemistry. We have around 750 products in our product range, which ranges from isophorone and its derivatives to amines and also isocyanates, as well as a very broad range of different epoxy curing agents that offer our customers a set of really versatile solutions for applications in the fields of like coatings, civil engineering, adhesives, and also composites, and also elastomers are some of our target applications. But today's focus will be on the product line epoxy curing agents. We as the product line epoxy curing agents, we have the ambition to be the #1 supplier for epoxy curing agents in the world. So as a product line epoxy curing agents, we currently have a global revenue of roughly €500 million at the moment. And we are serving multiple industries and are active in a very broad spectrum of applications field, as slightly outlined before. So besides the field of adhesives, which is the focus topic for today, we also serve like fields of composites, as well as the important fields of civil engineering, which includes prominent applications such as industrial flooring, for example, or the coatings field with anti-corrosive coatings for bridges or ships, for instance. With that, we have also a global footprint with production sites, as well as sales and development facilities across the whole world. So whenever you approach us, we operate basically as a global team and can therefore also draw from worldwide resources. So myself, I'm localized in Europe in our production site in Marl, Germany. And I have some colleagues responsible, for example, for the North American market. They can be found in Allentown, Pennsylvania, or other colleagues responsible for the Asian area. They are localized in Shanghai, China, just to mention a few here. What is also important to state at this point, we do not formulate adhesives. We only do the neat amines or the formulated amines or curing agents or building blocks for the epoxy curing. So we are not on a competitive situation with our customers who do the formulation of adhesives. On this basis, we want to support you as an adhesive manufacturer or developer as one of the decisive partners for driving your material innovation set and your change industry standards. And overall, we offer a large and versatile toolbox of a very broad range of epoxy curing agents, combined with also strong support from our side for an active and fast development at your side. To provide you some better orientation on the adhesive relevant portfolio of our epoxy curing agents, here on this slide I just highlighted the brand names which are basically of relevance for the adhesives and sealants market within the epoxy curing agents product portfolio. Some of these may already be familiar with for you. Others may come across in the course of this presentation. So in today's presentation, we will more focus on the product from the Ancamine and also the Ancamide product portfolio. These basically comprise a variety of aliphatic, cycloaliphatic amines, as well as amidoamines and also polyamide curing agents that can be used in a really broad range of epoxy curing applications. And also beside that, we also offer a range of dicyanodiamide grades under the trade names Dicyanax and Amicure, as well as different imidazoles and reactive diluents represented by the product lines Curazole, Imicure, and Epodil, respectively. So coming now to the actual topic of this webinar, which is sustainability. Here I will start with a brief introduction as a background information on Evonik's general sustainability strategy before focusing more specifically on the sustainability aspects of our epoxy curing agent portfolio, particularly for the adhesive applications. So what does Evonik's sustainability strategy 2020 plus, as it is called, looks like? Our sustainability strategy is currently based on 5 pillars, which state that sustainability is an essential part of Evonik's corporate purpose, that we operate forward-looking resource management, that our portfolio includes growth businesses with a clear focus on sustainability, and sustainability is integrated also in our strategic management processes. And Evonik sets itself high standards for the continuous improvement of reporting in that regard. Getting a bit more into detail on the sustainability strategy, the background of Evonik's strategy here is basically a framework of the 17 goals for sustainable development of human society, which was set by the UN in 2015, including the overall objectives like sustainable economic growth, social inclusion, and also environmental protection. And based on these 17 targets, Evonik defined 4 solution areas where we as a company want to get better, which are namely fighting climate change, driving circularity, safeguarding ecosystems, and ensuring health and well-being. Yeah, here we want to focus on our negative impacts we have with our business, the so-called footprints, and also the positive contribution we can achieve with our products, here the so-called handprints. So examples for footprint are reduction of water consumption at sites that are in water stress areas, for example, or reduction of hazardous emissions and waste in production, reduction of contents of substance of concern in our products. Or on the handprint side, we have examples like enable recycling of plastics, enable formulations that are water-based with a low VOC content, for example. And to set the basis for decision making, Evonik developed in 2019 together with other companies the so-called portfolio sustainability assessment. So this is a standard approach which was aligned to the specific requirements of Evonik in 2020 with a pilot for the segment Nutrient and Care. And according to the sustainability performance, the product portfolio is basically classified from the best category, which is A++, to the worst category, C-. And in 2021, this sustainability assessment was done for the complete portfolio of Evonik. And this is now part of our strategic portfolio management. In addition to that, Evonik has set further goals in various fields of action, highlighting here our 10 most important sustainability goals, also including those relating to occupational and plant safety, diversity, and also health protection. To mention some highlights, for example, regarding strategy and growth goals, for instance, Evonik committed to a share of at least 35% of the total sales, which must stem from so-called next generation solutions. These are products or solutions that offer a clearly positive sustainability profile, which is above the market reference. So the basis for identification of these is a framework utilized also for the portfolio sustainability assessment. Other highlights here are our environmental goals, where we committed to a really significant reduction of greenhouse gas emissions, as well as absolute and specific energy consumption. This is just to give you some examples and highlights on the 10 goals we have beside the general strategy. Now giving you a short outlook on the next generation solutions, which can be found across different business lines and product lines so far. Here I want to highlight particularly those which are, for example, based on renewable resources. This includes, for example, the Vesta Eco series, which comprises isoferone diamine, and also isoferone diisocyanate, which I will explain later in more detail, as it is also relevant for epoxy curing agents to some extent. And further, there are products from the Dynacol Terra, which are polyester polyols. Then we have a Polyvest Eco, which is butadiene rubbers, and also Vestoplast Eco, which refers to amorphous polyalpha olefins. So these are a series for adhesive and coatings applications here, also just to name a few as examples for our next generation solutions already available in our portfolio. But how can we address sustainability of epoxy-based adhesives with our current portfolio of epoxy curing agents? So this is an important question here. So when you take a look at an adhesive's life cycle, there can of course be found several ways in which the sustainability of particularly structural epoxy adhesives can be addressed and improved via the curing agent. So at the moment here, we are mostly focusing on the curing agent, not on the resin part. So starting from the raw materials perspective, besides corresponding energy and resource consumption, and also waste and EHS aspects, as well as logistics, the most obvious route to improve sustainability via the curing agent is to use curing agents that stem from biocircular or circular sources, or corresponding building blocks as basis for their synthesis. Regarding the second aspect, the aspect of application, there can be found some additional possibilities in which the curing agent can improve sustainability. This primarily involves an improved EHS and handling profile by substitution of critical raw materials or their modification, reduction of VOC contents, or change of the chemical basis, for instance. Concerning structural epoxy adhesives that require heat curing, for example, particularly one-component systems based on diamide, for instance, the process energy consumption is here a crucial factor in which catalysts, for example, or accelerators or alternative curing agents play a decisive role. And further sustainability aspects concern the end use of structural epoxy adhesives. Here, epoxy adhesives offer a clear advantage regarding performance, durability, required maintenance, and complemented by unusually uncritical EHS profiles and also low VOC contents. In addition, they can also be considered as an enabler for multiple sustainable technologies in which they are some kind of essential part or help to improve these technologies. And last but not least, regarding the end-of-life aspects, debonding as a crucial part of a reasonable recycling strategy can be considered as one of the most important factors here. Taking these life cycle considerations into account, we identified three major sustainability aspects which we can currently address with our portfolio of epoxy curing agents. The first and most obvious one covers epoxy curing agents that are based on or stem from biocircular or circular sources, such as polyamides, amidoamines, phenylcamines, or also some diamines. Whereas the second aspect focuses more on epoxy curing agents that improve the sustainability of the bonding processes, which includes, for example, a reduction of curing temperatures and times, particularly in the field of 1K adhesives, or come along with an improved EHS and handling profile, for instance. And the first and last aspect we will focus on today covers epoxy curing agents, which are an essential part of sustainable technologies or help to improve them. So this includes, for instance, wind energy market, or lightweight construction, and also electromobility. So starting with the first aspect, the epoxy curing agents that are based on renewable raw materials. These, for example, can be derived from bio-based building blocks such as fatty acid dimers, tall-oil fatty acids, or cadanol, which represents at the moment very well-established technologies. It's a state-of-the-art technology in this field of amine modification, and also contributes to improved handling and EHS profiles of the corresponding epoxy curing agents versus the neat amines they are usually derived from. But nevertheless, it must also be mentioned that the carbon footprint of fatty acids, even if they are derived from renewable resources, particularly in the case of dimer acid, is not automatically small. Further, there are also amine curing agents that are synthesized from bio-based materials, one of which is the isophorodiamine, which was recently introduced by Evonik as Vestamine Eco, which I also will explain later in more detail on a separate slide. And then we have like diamines, which are derived from terpene limonene, for example, the limonene diamine. Then we have, for example, diamino isosorbate based on starch, just to mention a few out of a really wide range of potential bio-based amines which have already been discovered. But nevertheless, there are also some challenges which particularly involve limited industrial availability, the challenging production or processing, as well as usually higher price levels which come along that, and in some cases also questionable performance or critical labeling, which in total limits a broad application and also commercialization of such amines. So concerning epoxy curing agents in our portfolio for adhesive applications that are based on renewable raw materials such as the fatty acids or cashew nut oil, here Evonik offers a series of amidoamines and polyamides and also phenylcamines under the trade names Ancamide and Ancamine. So these can, based on the ratio of fatty acids or cadanol, they can include up to like 70% of their raw materials from renewable resources. So these are, for example, the Ancamide 260A, 350A, or the Ancamide 500 series, or the Ancamine 2719, which is a highlight for the phenylcamines in our portfolio. Just to name some prominent examples here on based on that technology. All these products, they are based on established and really highly reliable technologies, and representing a state-of-the-art technology, and they offer high performance and also compatibility in adhesive applications, including also an improved EHS and application profile versus the amines they are usually derived from. Hence, they are suitable for also a broad range of applications and also tailored solutions on our customers' side. So now let's briefly switch to an even more interesting topic. Our Vista Eco product series, which was introduced in March this year, representing the iChain product, Vestasol IP, the isoferone. Then we have Vestamine IPD, which is isoferone diamine, and the Vestanat IPDI, which is the isoferone diisocyanate, which are all made from raw materials which originate from renewable feedstock. So how do we do this, and what is important here is also, it's important to mention that the basis of this product series is a ISCC standard mass balance approach, in which the raw materials from also crude oil and the renewable raw materials from certified sources are used in the same process. And the certificate, this allows us to allocate the corresponding amounts of products stemming from the renewable feedstock in the end. And using this approach, this also means that the eco products, they do not differ from their conventional counterparts, neither in their physical or performance properties or in their properties at all. And therefore, they help our customers to improve their CO2 footprint or emissions very efficiently by a real drop-in solution here. So now let's come to the next sustainability aspects in our portfolio, the epoxy curing agents that help to improve bonding processes. So here we have epoxy-based adhesives that often involve elevated temperatures, particularly in the 1K adhesive systems, like diamide-based adhesives, for example, and hence an effective reduction of curing temperatures and also curing times is an important step to improve sustainability of ejected processes. As an example, we have a series of modified aliphatic amines, such as the Ancamine 2014 AS and FG grade, the 2441 and 42 grades, and the 2337S grade, which all allow a significant decrease of curing temperatures for 1K systems, with the Ancamine 2337S down to 80 centigrade when it's used as a sole curing agent, or down to around 120 centigrade in case of the 2441 if it is used in connection with diamide as an accelerator. So this directly contributes to lower CO2 emissions in the bonding processes. All these products, they offer a really fast property development, and in also some cases they can be used for applications that require snap cure capabilities. And this is also complemented usually by high performance, and also they come along with quite long latency potential even at elevated temperatures. So in case of the 2441, for example, we can achieve like shelf life of around 3 months at a temperature of around 40 centigrade, just to give you an example here. Coming now to another product which helps to improve sustainability of bonding processes, in particular in the field of 2K adhesive systems, which is the Ancamine 2914 UF, which is a quite new product, and it was designed as a mercaptan competitive ultra-fast epoxy curing agent with really fast property development, also coming along with excellent mechanical properties and also good adhesion properties. And Most importantly, to say here, it is a TO-free product, and therefore, it comes along without any sulfur odor, which in this case helps to improve handling and application properties in the bonding processes. In addition, it's also worth to mention that it offers lighter color and improved yellowing over the mercaptan-based systems, which is an additional advantage over them. And last but not least, let's now come to the third sustainability aspect we choose for today. So these are the epoxy curing agents that are enablers for sustainable technologies. So one prominent example here is the Ancamide 3030, which is a cost-effective industry standard, which is predominantly applied in adhesive formulations like for wind turbine rotor blade production, as an example. And to address the trend for even larger rotor blades and the corresponding challenges in manufacturing of these, we recently also extended our portfolio with the Ancamide 3130, which can be seen as an advanced version of the 3030, which comes along with a similar set of properties, but with the advantage of significantly extended gel times and also some improvements in the thermal resistance here. Other product examples are the Ancamide 910 and the Ancamine 1922A. Both of these products are highly flexible and they are low viscous epoxy curing agents, which provides our customers an advanced tool to cope, for example, with the challenges of bonding dissimilar materials in lightweight construction. As both of these curing agents, they enhance adhesion and peel strength on different materials such as steel, aluminum, or other engineering plastics. And also they come along with a quite good flexibility and projected thermal shock resistance to the corresponding joints. And this is, as already said, complemented by low viscosities that also allows for epoxy systems the formulation of highly filled adhesives such as thermal interface materials, which help to improve the temperature management of battery packs, for instance. So now coming close to the end of my presentation. So in summary, it can be concluded that sustainability in the field of structural epoxy adhesives is a quite versatile topic, especially with regard to the aspect of curing agents, and that cannot and of course must not be reduced only to renewable resources alone. And rather, I would say that all aspects of the life cycle of an epoxy adhesive must be taken into account as far as possible, which, as outlined, includes not only the raw material aspects, but also the aspects of application, end use, and also the end of life. So in this respect, there's already a variety of solutions on the market that address these aspects, but nevertheless, of course, there's still much room to improve sustainability in the field of structural epoxy adhesives. And if that sounds good to you and you think we can support you, please do not hesitate to get in touch with us. If you want to search on your own, please take a look on our website with our product finder, which will to some extent help you to find the right products. But for more personal and more specific support, please contact me for the EMEA region, or one of my colleagues shown here as Shafiq Fazel for the US area, or Fuji for the Asian area. And with this, I'm at the end of this presentation, and please feel free to ask me any questions or contact me later on any topics related to our epoxy curing agent for adhesive applications.
Okay, everyone, as we move into Q&A, please remember to put your questions in the question tab located on your screen, and we will try to get through as many as we can. Our first question: are there any sustainability relevant data available for your products such as LCA, CO2 in kilograms, or similar?
This is a topic which is, I would say, currently focus of some ongoing project we are doing at Evonik. So I think in the near future there will be some data like life cycle analysis for some products. For the beginning, I think we may or rather focus on the more important product before we also have these data available for like smaller products. So as you can imagine, if we have like 750 different products globally, this is a huge amount of work to get a life cycle analysis for all of these. But this is, I would say, an object of currently ongoing projects. Yeah.
Okay, great. Thank you so much, Sebastian. Our next question. Can I get a sample of Vestman IPD Eco?
Yeah, this is a question which is asked quite often. So there will not be a specific sampling of the Vestamine IPD Eco. Yes, I outlined on this slide. Due to the mass balance approach, or the reaction, if you use the renewable feedstock or the feedstock from crude oil, it is basically processed in one reactor, I would say, and only the certificate in the end allows us to allocate the ratio of material which is based on the renewables. In the end, it would not matter if you get a sample of Vestamine IPD or let's say IPD Eco, because they are basically the same. The only difference will be the certificate you get on this. Yeah.
Okay, great. Our next question. How do you address the end of life topics such as debonding and recycling?
Yeah, this is really one of the challenging topics in the end of life considerations of an adhesive. So debonding, we also identified one of the most important topics here, also to enable or to improve the recycling of the bonded materials, rather like to recycle compounds from the adhesive, as the mass of adhesive is usually quite low. So here's for us more interesting to enable like debonding technologies that improve like the recycling of the whole part in the end. Regarding that, there are at the moment, I would say, some projects going on at Evonik, but at the moment I would say there's no solution which is close to a commercial state at the moment. Yeah.
Okay, great. We're seeing a few questions about whether the recording and the slides, what's going to be available after the event. Yes, we will send you the recording of today's event, as well as, the presentation and contact information for Sebastian, so please don't worry about that. Our next question, what is the curing time of Ancamine 2914UF with AF resin at 10 and 20 degrees Celsius?
Mm-hmm. Yeah, he kind of say that usually if we take room temperature curing into account, that the gel time of the 2914 UF is around 8 minutes, I would say, which is slower at lower temperatures. So at temperatures of around 10 centigrade, it is much slower. So we rather recommend this product for room temperature curing applications than for low temperature curing. There it might not be the right fit at the moment, I would say.
Okay, great. Thank you so much, Sebastian. That was our last question of today. So thank you all again for attending today's event. Just as a reminder, we will send you a link to the recording of today's event so you can watch it and share with others at your company. We will also follow up 20 questions we weren't able to get to today. Thank you again for attending and have a great rest of your day.
Yeah, also from my side, thank you very much for attending and looking forward to get in contact with you.